Okay, we're going to do another quick video on our single output up and single output down, sometimes called a hot shot or a one shot or a change on rising edge or falling edge. And we'll talk about the difference between the two. So first things first, I've got my program here. We just created an example for a set and a reset output type. So we're using a normally open push button on input 0 for starting our green light, turning on our green light, and we're using a normally open push button at input 1 to switch our green light off, right? So the start button sets output 0, and the red button, our red stop button, resets our output. I want to put in a one shot or a single output up, and I'll click on that. So I'll go into the basic instructions, find my single output. The shortcut is SOTU. I'm just going to click it for now, and I can drop it anywhere in here between the instruction that I want to trigger that one shot or single output. It's like a pulse, and then the output that I want it to affect over here. So when I go into my simulation, you can see how this behaves a little differently, where I can set this, and if I leave this set, I can still reset or set my stop button, and it resets the output. But if I reset this, so that's like, I've let go of the stop button, but I'm still pressing the start button for some reason, right? If you haven't had your first cup of coffee yet and you forgot to take your finger off the start button, nothing happens over here, because the transition to establish that logical continuity only happens on the initial changing of the state of this bit so we're dealing with a digital signal, right? So it's either on or off. It's a 1 or a 0. So when this makes that transition from off to on, that rising edge, right? We go from 0 to 1, or the state of the input is 0 volts to 24 volts. Only when that happens does this instruction allow that logical continuity to change the state of the output. So even though this is still held high, nothing is happening. I have to actually let go of the green button and then press it again in order to get this to change states again over here on my output. Okay. So we'll do the same thing here. And if I set this, you'll see I can reset, and then I can set it again, and nothing happens, because this is holding the reset, and that's always going to switch that output off. So as long as I'm pressing the stop button, I'll never be able to start the green light, or I'll never be able to turn it on, no matter what I do. Unless, if I put in, I'm going to go out of my simulation mode, if I put in another single output up, now when I go to simulate, I can reset this, and when I set this, and I'll reset it, because that's how it would behave normally, right? I push the button and let go, and then I set this, and let's say I don't release the button, right? And remember, before, that prevented me from being able to turn on our green light. But now when I set it, I'm able to switch that green light on, because this allowed that logical continuity when this was first established on, or a 1 or high, and then it broke that logical continuity. Because for a set and a reset, I only need that brief pulse, and it only happens in that transition from low to high. So that allows me to press this, set it. I can reset it. That's already established my latch. And then this I would have to actually let go of the button now. And then I can set it again, and that resets everything. Okay. And then our single output down, it just triggers or does that transition on the falling edge of our signal. So it's when we go from set to reset on these instructions, that is when we would allow logical continuity, just for a brief moment. It happens in the time of milliseconds, so it's not something that you'll ever really see represented in here, or if you're going into monitor mode and trying to look for it, you really won't see it. But it's a good way to prevent weird behavior if a button sticks, and we can treat things that might otherwise be maintained as a kind of the same way we treat a momentary button press. So it gives you some ability, these single outputs, whether it's up or down, gives you some ability to kind of gain functionality you need with bits that might not otherwise behave the way you need them to behave, right? Like, so it lets you treat things like momentary buttons even if they aren't momentary buttons. We could use a maintained selector switch and treat it like a momentary button using one of these single outputs. So kind of nice and very useful, and we'll use them quite a bit in class. So just wanted to show you that, and I will see you guys later.